A massive labor strike involving 45,000 workers has erupted at Samsung's memory chip facilities, and it is about to change how you understand the entire artificial intelligence boom. This is not a public relations crisis for a single company. It is a critical stress test revealing that the physical supply chain is far more fragile than the headlines suggest. By the end of this video, you will understand why the speed of AI growth is no longer limited by code, but by the hard limits of silicon manufacturing and advanced packaging. To grasp the magnitude of this disruption, we have to look past the software narratives that dominate every tech news cycle. We hear constantly about new models, faster algorithms, and breakthroughs in natural language processing. The assumption is that if we just write better code, the AI boom will continue to accelerate indefinitely. That assumption is fundamentally wrong. The reality is that artificial intelligence is a physical phenomenon. It requires physical matter to exist, and that matter is being assembled in some of the most complex manufacturing environments on Earth. When a workforce of 45,000 people stops working, it does not just slow down a factory line. It halts the production of the very hardware that powers the global AI infrastructure. Here is the thing that most analysts miss. They focus on the software layer because that is where the innovation is visible. But the software layer is completely dependent on the hardware layer and specifically on advanced packaging capacity. The term advanced packaging refers to the process of stacking multiple memory dies, such as high-bandwidth memory, on top of logic processors to create a single high-performance unit. This is the bottleneck. Without this specific type of assembly, the most powerful AI chips cannot function at the scale required for training large models. The strike exposes a critical vulnerability in the just-in-time model that the semiconductor industry has relied on for decades. This model assumes that supply chains are continuous and that labor forces are stable. When 45,000 workers walk off the job, that continuity breaks instantly. Because of this stoppage, the flow of components required for AI clusters comes to a halt. This is not a minor delay. It cascades into a months-long disruption for the entire deployment pipeline. Companies that were planning to deploy new AI clusters are now facing a reality where their hardware simply does not exist. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider the specific constraints of advanced packaging technologies like CoWoS, which stands for Chip-on-Wafer Substrate. This technology is essential for connecting memory and processors. The industry has been operating at full capacity for years, with very little spare room for error. A disruption at a major node like Samsung does not just affect Samsung, it affects the entire global ecosystem because the supply chain is hyper-concentrated. There are very few facilities capable of producing these advanced packages at the required scale. When one of them stops, the entire system grinds to a halt. This crisis shifts the narrative from software adoption speed to physical throughput. We're seeing a clear distinction between software scalability and physical hardware constraints. Software can be duplicated infinitely. You can copy a model from one server to 1,000 servers in seconds. Hardware cannot be duplicated instantly. It takes months to build a new fab, years to qualify a new process, and years to train a workforce. The lead time required to retool and staff advanced packaging lines is now the primary determinant of when the next generation of AI growth can occur. The research into AI automation and labor dynamics suggests a theoretical model where software efficiency gains are irrelevant if the physical silicon cannot be assembled. This is exactly what we are witnessing now. The timeline for next-gen AI growth is capped by the time it takes to get workers back in the factories and restart the complex assembly lines. Algorithmic breakthroughs are happening, but they are hitting a wall of physical impossibility. You cannot train a larger model if you do not have the memory chips to store the weights. You cannot deploy a faster inference engine if you cannot assemble the processor packages. This event serves as a stress test for the industry's reliance on a hyper-concentrated geographic supply chain. The fragility of this model is now undeniable. A single node stoppage has revealed that the entire AI boom is dependent on a handful of manufacturing sites. The labor strike is not just a dispute over wages or working conditions. It is a demonstration of how thin the margins are in the physical world. When the physical world stops, the digital world stops with it. The implications for the broader economy are profound. We are moving from an era where the constraint was algorithmic complexity to an era where the constraint is physical throughput. This means that the velocity of AI growth is now dictated by the speed of manufacturing, not the speed of coding. Companies that were betting on rapid scaling are now forced to confront the reality that their hardware supply is the limiting factor. The strike has forced a reckoning with the fact that silicon manufacturing bottlenecks, not software optimization, dictate the AI boom's velocity. This is the critical insight that changes everything. The AI boom is not a software story. It is a manufacturing story. The 45,000 workers on strike are the ones who actually make the future possible. Without their labor, the most advanced AI models remain theoretical. The strike reveals that the physical supply chain is the true constraint on AI scaling, proving that silicon manufacturing bottlenecks are the primary limiter of the industry's velocity. The path forward requires a fundamental shift in how we view technological progress. We can no longer assume that software innovation will outpace physical limitations. We must recognize that the physical world has its own rules, and those rules are non-negotiable. The next phase of AI development will be defined by how quickly we can expand physical capacity, not how quickly we can write better code. The strike has shown us that the future of AI is built on the factory floor, not just in the server room. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.